Today's lesson is on similar polygons. Our objective is to identify and apply similar polygons. So the definition of similar figures have the same shape, not necessarily the same size. You can abbreviate similar with the symbol, which looks like a little squiggly here. So a sideways S is similar, whereas we know that the equal sign with the squiggly on top is congruent. But just the squiggly itself means similar. You can use ratios and proportions to decide whether two polygons are similar and to find unknown side lengths of similar figures. So, similar polygons. They are same shape, different size. So we have same shape. It can be different size. And we have corresponding angles will be congruent. So similar polygons are similar shapes. They are same shape, different size. And again, you have your congruent symbol, and now we have our similar symbol. So our key concept here is two polygons are similar polygons if corresponding angles are congruent and the corresponding lengths are proportional. So just like we had a congruent statement, we also have a similarity statement. Okay, similarity statement tells us what angles are congruent to what angles and what ratios of the sides are going to be equal. So I have a trapezoid and I have BCAD and HIGJ. I know that my angles are corresponding congruent, so B goes to H, C to I, A to G, D to J. Okay, so the angles have to be congruent correspondingly. And the side lengths all have to have the same ratios. So the ratios between A to B over GH is the same as the ratios of BCHI, CDIJ, ADGJ. So again, similar polygons. Angles are corresponding congruent, and the ratios between corresponding sides is also congruent. So when you have a bunch of ratios set equal to each other, we call that the extended proportion. So I can do another example here. I have a pentagon, and I will make it bigger and smaller. So I can say that these two pentagons are similar. So as long as I show that I have corresponding angles congruent, which I'm doing here, okay, so my corresponding angles are congruent. I'll label this A, B, C, D, E, F, M, N, O, and P. So these are similar pentagons. So I know that A, B, C, D, E is similar to, now what corresponds to A? F. What corresponds to B? M. What corresponds to C? N. What corresponds to D is O. What corresponds to E is P. So my corresponding angles are congruent. Also, my side lengths also have the same ratio. So here's an example. If I have a side length of, in this case we'll do 2, 3, and then we'll do 2, 2, and 3. Then I'll do my new side lengths over here. I'll have 8, 12, 8, 8, and 12. So same shape, different size. My angles are corresponding congruent, and now I have to show that my proportions between the sides, in other words, the side ratios, all have to be the same. So I have to show that A to B divided by F to M is the same as B to C over M to N, C to D ratio over NO, and we have DE over OP, then we have EA over PF. I have to show that all those ratios are the same. And if all those ratios are the same, then I have shown that these two similar figures are indeed similar. So my AB length is 2. My FM length is 8. Is that the same as BC, which is 3 over 12? CD is 2 over 8, 2 over 8, and then we have 3 over 12. Well, let's reduce these fractions now. 2 over 8 is 1/4. 3 over 12 is 1/4, 1/4, 1/4, 1/4. So since all my side ratios are congruent, I know that the pentagons are similar. So I know that the shapes are similar. So there's your example of a similar polygon. Now let's apply it to a different example. So I have two triangles, okay, MNP and SRT. They're similar. I know they're similar because I gave you the similar statement. Part A says, what are the pairs of congruent angles? Well, I can use my congruent statement to get my congruent angles. So I know that angle M is congruent to angle S. Angle N is congruent to angle R, and angle P is congruent to angle T. So remember, angles are congruent, side lengths have to have the same ratio. So what is the extended proportion of the ratios? Well, starting from the first two letters, I know that MN ratio over SR is the same as NP RT, and we have PM and TS. So that is my extended ratios. Now I don't know the actual numbers for these measurements, but I can write out my statements because I know that they are similar. Up top here we have a scale factor. Basically, once you know that all sides have the same ratio, that ratio is called your scale factor. So in my previous example, let's go back, all the ratios were 1/4. So these are also my scale factor. So my scale factor is also 1/4, meaning that the left-hand side is 1/4 times bigger than the right-hand side. So that's your scale factor. So the scale factor is the ratios of the corresponding sides. So let's try this. I have a quadrilateral and a quadrilateral that are similar. What are the pairs of congruent angles? Well, part A is easy. Use your statement. D is the same as H. I have E is the same as J. I have F the same as K. And I have G the same as L. So those are all my corresponding angles. Remember, corresponding angles are congruent in similarity. And my extended ratios mean that all the ratios between corresponding sides are also congruent. So I have DE over HJ ratio is the same as EF over JK ratio, same as FG over KL ratio, and I have GD over LH. And remember, all these, this is my scale factor. So let's actually see if we can tell if two shapes are similar if I don't give you the similar statement. So I gave you two quadrilaterals. I want to know if these are indeed similar. Well, my steps are to identify pairs of congruent angles. So in order to determine if two polygons are similar, the first thing I would do is determine, are all my angles corresponding congruent? Well, let's look. I know that K and U are in the same position and they're both congruent, so that's true. J and T, they're congruent and corresponding two arcs and two arcs. I have M and W, they're congruent, single arc, and I have L and V. So yeah, all my angles are congruent. So I do have all angles corresponding congruent. So that's step one. Step two, I need to now make sure that my corresponding sides all have the same ratios. Okay, well, I need to know, is JK over TU the same as JM over TW? We have ML over WV, then we have LK over VU. So are all those ratios going to be the same? Well, J to K is 12, T to U is 6, J to M is 6, 6, M to L is 24, 14, 24, 16. Well, are all those ratios the same? So we have to simplify. So 12 over 6 is 2 over 1, 1 over 1, 24 over 14 is, we can reduce that to 2 goes into both, so that's 12 over 7. And then we have 24 over 16, which is 3 over 2. So my ratios are not the same. So these are not congruent. Therefore, this is not similar. So even though my angles were congruent, my ratios were not the same. Therefore, they are not similar figures. Why? Because the ratios between corresponding sides were all different. Let's try another one. Two triangles. Let's see if they are similar. Well, I know that A and E are equal. Oh wait, oops, sorry, not A and E. A has 2 arcs, D are equal. B has 3 arcs, that goes with E, and C goes with F. So I do have corresponding angles congruent. Now I need to do the side ratios. So my side ratios, I have my AB ratio, or sorry, not my AB ratio, my AB side. Okay, AB side gets compared to DE. I have my BC side. BC side gets compared to EF. And then I have my CA side, which is FD. So let's compare these ratios. My AB is 12, DE is 15, BC, which is 16, EF is 20, CA is 8, FD is 10. So let's reduce. 3 can go into 12 and 15, so that's 4 over 5. 16 and 20, that's 4. That's 4 over 5, reduced 2. And 2 can go into 8 and 10, so that is also 4 over 5. So all my side ratios were the same. These are all congruent. All my angles are corresponding congruent, so these are corresponding congruent. So since both are true, I do have triangle ABC is similar to. Now what goes with A? D. What goes with B? E. And F. So those two triangles are indeed similar. So are the polygons similar? If they are, write a similarity statement and give the scale factor. Let's go back to this one. My scale factor is 4/5. So my scale factor in this case is 4/5. All right. So I know that all my angles are congruent. So do I have congruent corresponding angles? And they are yes, because they're all 90. Step 2, I need to make sure that my ratios all have the same sides. Well, okay, these are all 90-90. I know that this is 10, and that's 15. And this is 15, and this is 20. Now, this one's a little tricky because you got to remember that, okay, you're not comparing 15 to 15. When you're only given two parts, like we had here, given two sides and two sides, you compare the small to the small and compare big to the big. So in this case, I want to make sure that my KL is getting compared to X, Y, and my KN is getting compared to WX. So KL, in this case, is 10 over 15. Is that the same as 15 over 20? We have to reduce it. 10 over 15, 5 can go into both. So that's 2/3. 15 over 20, we have 5, so that's 3 over 4. So these are not congruent ratios, therefore they are not similar. So let's try this one. The letter B. 1. We have angles corresponding congruent. It is yes, all my angles. I have B with R, C with B, D with U, A with S, E with T. Yep, so now I need to check my ratios. Check the ratios. So my ratios that I need to check. I have BC, RV. I have CD, VU. I have DE, UT. I have EA. I have TS. Then I also have AB, SR. So are those ratios all the same? Let's check. Well, B to C is 18. R to V is 9. C to D is 18. And this is 9. D to E is 12, 6, 12, 6, and 18, 9. When I reduce, I have 2 over 1, 2 over 1, 2 over 1, 2 over 1, and 2 over 1. So these are all congruent ratios. So these are congruent ratios. All my angles were corresponding congruent, so these are similar polygons. So remember, since all my ratios were the same, this is also my scale factor. So the scale factor is 2/1. So let's write our similarity statement. Scrolling back up, my similarity statement, I have A, B, C, D, E is similar to A goes with S, B goes with R, then I have V, U, T. So letter A, these were not similar because the ratios were not the same. Letter B, they were similar because corresponding angles were congruent and all the ratios between the corresponding sides were also congruent. They were all 2/1. So let's try the similar trapezoids. So I have similarity of ABCD is similar to EFGD. What's the value of X and what's the value of Y? So what I'm going to do is I am going to retrace. My two trapezoids. I can't assume they're trapezoids because I don't know that AB is parallel to DC. So I just redrew my two trapezoids. So let's write them out. So here's D, here's E, here's F, G, here's D, A, B, and C. And I know that they are similar. How do I know they're similar? I tell you in the similarity statement. So I have 6, I have Y, I have X, I have 9, 5, and 7.5. So since I know that they're similar, I know that they all have corresponding angles congruent. So step 1's already done because I already know they're similar, so therefore all corresponding angles are congruent. So step 2, I have to know that the ratios are all the same. Well, I already know they're the same because I tell you that they are similar. So DE gets compared to DA, EF, and AB, FG, BC, and I have GD, CD. So all these ratios are going to be equal. Why? Because I already tell you that the two polygons are similar. Well, D to E is 6/9. E to F is Y/5. And I have F to G, X/7.5. GD, CD is not used. So this is not used. So to solve these types of problems with variables, once you set up your extended ratios, so here's my extended ratios, you want to pick the fraction that has no variables, so the fraction that has no variables, 6/9, and set up a proportion with another fraction that contains one variable. So set up a proportion, which is a fraction equal to a fraction. What's another fraction that has only one variable? It's Y/5. So how do you solve a proportion? You do cross multiply. So I have 6 times 5 equals 9y. So I have 30 equals 9y, divide by 9, divide by 9. So therefore, y is equal to, you reduce it, 3 can go into both. 3 goes into 30 10 times, 3 goes into 9 3 times. So there is y. Y equals 10/3. To solve for x, again, pick the fraction that has no variables, so 6/9, and set it equal to the other fraction that has a variable. The other fraction that has a variable is x/7.5. So when I cross multiply to solve for x, I have 6 times 7.5, which is 45. So 6 times 7.5 equals 9 times x, which is 45, equals 9x. Therefore, x is equal to 5. And those are my answers. So solving for a missing variable, knowing that the shapes are similar, set up your extended ratios, pick the fraction that has no variables and set it equal to the fraction that has one variable. Cross multiply and solve. And repeat again if you have more than one variable to solve for. With similar polygons, you also have scale drawings. You see these on maps, usually, where they tell you that a centimeter is 50 kilometers, or an inch is 100 miles, or an inch is 10 feet. So you can use a scale drawing to solve for distances between two towers. And then I have a scale drawing problem. The diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. What is the actual length of the main span of the bridge? Well, to do this, I tell you that 1 centimeter is 20 meters. So what you have to do is get out your ruler. So here's my ruler, and you measure. So I have to do inches. So the distance between the, let's zoom in here. So the distance between the main spans, okay, so I have a main span right here. And I have a main span right here. Okay, so I have 1 centimeter is equal to 200 meters. So here we go. So here are my centimeters. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like 12, 12 and a half. We'll go with 13. There we go. I'll adjust it and cheat a little. So there we go. So the length on the map is 13 cm. So how does that relate to the real world? Well, for every centimeter, it's 200 meters. So let's set up our ratio. So I have, for every 1 centimeters, it's 200 meters. Therefore, if I have 13 centimeters, how many meters is that? Let's cross multiply. I have x is equal to 200 times 13. Therefore, x is equal to 200 times 13 is 2,600 feet. Or sorry, not 2,600 feet, 2,600 meters. Here are some practice problems you can do on your own. And also try the homework. If you have any questions, send me an email, ask questions during class. So the key here is similar polygons. Let's review. Similar polygons. Same shape, different size, corresponding angles are congruent, and now we can also add similar polygons, also have congruent ratios between corresponding sides. So the angles have to be congruent and the ratios between the sides have to be congruent in order to be similar.